Okay, good morning. Okay, so let's start the class. So today we will talk about a new topic, and we are going to talk about function. So let me give you a definition first. So this concept, I guess you should have used that quite often already from your high school. And this is a formal definition. So what is a function? So let's say f is a function. And then whenever we talk about a function, we need to associate with two sets. So we call a function f from a set A to another set B. It is an assignment of exactly one item of B to each item of A. So what does it mean? Okay, so we have a set A. So let's say set A contains items 1, 2, 3. Okay, and then let's say set B contains items the sun, the moon, the star, the Jupiter, the Mars, the Earth, whatever. Okay. So if it is a function from A to B, then for each item in A, let's say item 1, we need to find some item in B and exactly one item in B that assign this one to that item of B. I will give you an example very shortly, but there are two key points that we need to understand. It is that, okay, the assignment should work for each item of A. So every item in A, you need to find something in B to correspond to it. And then there is only one item in B corresponding to any item in A. So for a particular item in A, it has only one correspondence in B. It will not map to two different things in B. So let's have an example. So suppose that we have students in a class taking the exam, and then we have the grades. Okay. We have the grades. Okay. So let's say in particular, in our class there are only 4 students from the story of Doraemon. Okay. So let's say the first one is Da Xiong. Okay. So Da Xiong, the Japanese name is Nobita. So this is Da Xiong, okay. And then there is Jin Xiang. So the other one is Shizuka. So Shizuka is I don't know. Okay, so this is Shizuka, let's say. Okay. And then the third one is Takeshi. That is very fat. Okay. Or Jian. Okay. And then the last one is, let's say, the one who is richest. How do you call it in Chinese? Xiaofu. Okay, very good. Okay. So in Japanese, it's called Suneo. Okay. So what is okay? So he has a mouth like this. Okay. Okay. So let's say the grades could be A, B, C, D, E. Okay. And then as a result of this exam, let's say Nobita gets E, and then Shizuka gets A. Let's say Suneo gets B, and then Jian also gets E. Okay. Then this is an example of a function. Okay. So here the function, this is the set, this is one of the sets that each item in this set is mapped to one item in another set. So this is another set. So we have the set of students and the set of grades. And this is representing a function from the set of students to the set of grades. Is that okay? So it is a function. It is because of what? So first of all, let's check. Okay, let's check two things. One is for each item in the first set of students, do they always have an assignment to some item in the other set? If it is so, then it is okay for this condition. Each item should have an assignment, okay, in the other set that correspond to it. Is that okay? And on the other hand, we also check the other side. And then we see that, okay, for each one of them, for each student in the first set, it is mapped to only one thing in the other set. So this is the other condition. Exactly one item of B is mapped to each student. Is that okay? So notice that on this set of B, there may be multiple students mapping to the same item in B. That is okay. What is not okay is, let's say Shizuka is mapping not only to A but also to C. Now, if this is the so-called assignment, then this is not a function from the set of students to the set of grades, because it is one thing in A mapping to more than one thing in B. If you are okay with the definition of a function, could you please raise your hand? Okay, excellent, excellent. Okay. So let's say in the exam, let's say Nobita is very sleepy and didn't attend. So he didn't go to the class. So he didn't receive any grade. So this will be what is seen as a result. So Shizuka is A, Suneo is B, and then Takeshi is E. Is this an assignment? Is this an assignment from the set of students to the set of grades? Is it? No, this is not. The reason is that we need everyone to be mapped. So this is called a mapping. Okay, we should map everyone in the set A to some body, at least one body, okay, or exactly one body in the other set. So this is not okay. And this is the original one, and this is okay. Okay, so this is the function. Now, once we have defined a function, so there are some terms that I want to introduce. So first of all, a function will have a name. So here in our function, let's call it f. Okay, a name. And then this function has this property. So function of, so we can describe the picture, the relationship there using this representation. The function of this Nobita turns out to be the grade E. The function of Shizuka, okay, Shizuka is this one, is equal to A because she has grade A. The function of Takeshi is equal to E, and the function of Suneo is equal to B. Okay. So we can write down the relationship of that one using a representation like this. So this is the function name, and then this is some item in A in the first set, and then it is equal to some item in the other set, and this is the mapping from the item in the first set to the item in the second set. Is that okay? Okay. And then, so anytime a function has to be defined based on two sets, the original set that contains the item and the other set that contains the item that is mapped from, okay, another set. So in this case, we, for that particular function, it is a function that do what? That maps the set of students, okay. So this is a set of students, the set of students to the set of grades. So we can describe the property of that function like this. So it means, this is a shorthand notation. It just means that for any particular item in this set, it will have a correspondence in this set. Okay? Is that okay? Good. And then, okay, and then there are also some other name. Okay, so this one, this set, we usually call it the domain of f. It is the domain of this function f. Okay, domain means the home. Okay, the home. And this one, this is called the codomain of the function f. Okay, and there are also, so let's take in the particular example of the function value. So the function of Nobita is E. Okay, so E, this is also, there is also called another name. E is called the image of Nobita. Okay. Okay. With respect to this function f. Okay. Under the discussion of the function f, if you put Nobita as the input value of this function, you get the value e. So e is called the image of the Nobita. Okay. Okay. And there is one more description. Okay. One more thing. So we have defined what is image, right? And then finally, the set. So this is finally the set of all the images. What is the set of all the images? In our example, the image value could be E, could be A, could be B, but it is not C and D, right? There is nobody mapped to C or D. So C and D are not image of anyone, but A, B, E are image of some other person. So the set of image will always be a subset of the codomain. Am I correct? So if we just focus on values that really corresponds to the image of somebody else in the domain, then this set has to be a subset of the codomain. Am I correct? And then we give it a name. So this set of image has a name. We call it the range. Is that okay? So it is the range of what? So it is the range of the domain. Okay. So if you are okay with, so this is the range. If you are okay with all the descriptions so far, so these are only definitions. But if you are okay with this, could you please raise your hand? Okay, good, excellent, yes, excellent. So now we have defined these things, so we can talk about some special functions. So function is whenever it satisfies the property that it is assigning each item of A to some item in B, then it is a function. There are numerous functions. There are countless, infinite number of functions. But some of them has some property that we want to talk about. So we are going to describe three different types of function that has special property. The first type is called one-to-one. So the first type is called one-to-one function. The second type is called onto. And the third one is called what? The third one is called one-to-one onto. Okay. Okay, so what are they? Okay, so what is meant by one-to-one function? One-to-one function has a further restriction. Each item of B can only be the image of only one item in A. Okay? Okay, so one-to-one. It can, so here, Shizuka is mapped to A. One thing is mapped to one thing. Tsuneo mapped to B. One thing mapped to one thing. But we can see that Nobita and also Takeshi, these two persons in the student set, they are mapped to the same item in B, right? So this is called 2-to-1. There are two things mapping to one thing. Is that okay? So it is not called one-to-one. So a one-to-one function is every one item maps to one item in the other set. There is no two items or three items or four items mapped to the same item in the other set. Is that okay? Is that okay? Good. That's it. That's called the one-to-one function. Okay? So one-to-one function has another name. It is sometimes called an injective function. So it is called an injective function, or sometimes it is simply called an injection. Okay, so what is an injection? Okay, in English, have you heard of, okay, if you have seen the word injection before, could you please raise your hand? Nobody? Yes. So where did you see that? Where is injection? Hmm? In classroom. Well, okay, maybe, but more commonly it is in a hospital. What is injection? Yes, very good. Injection is you take a shot. Injection. You inject some medicine okay, this is injection, right? So if you meet, so sometimes if you are, let's say, unfortunately, if you are very, very sick, you need to have multiple shots. Then what will your nurse do? So a kind nurse, okay, should do something like, if you have multiple shots, put a shot one here, and find another place for another shot, right? Okay, it is because if she is going to take multiple shots at the same place, it is more difficult to recover. Okay, so injection is like every time you have a new shot, you should find a new place. Okay, of course, if you are really, really, really sick, then what you normally do is that, okay, the doctor will or the nurse will help you to have something here, and then, okay, so something like this. So let's say this is your arm. Yeah. Okay, and then they will put a device here. Okay, so plug it into your vein, and then, okay, and then there is a hole here. Then every time a new injection goes into this place, and then change it. Okay, I don't know whether you know what I'm talking about. So if you are really, really sick, then they have just put one thing here and then change the shots here again and again. So, but still, okay, there's only one. Okay, but if you are not that sick, okay, let's say if you are bringing your little brother or little sister to the hospital for injection, so one shot will be on this arm, maybe another shot maybe on this arm. Okay, so this is the reason why we call it one-to-one. Okay, every new shot you find a new place. So every new item in A, you find a new item in B to map to it. So it is called injection. Is that okay? Okay. Now, so this is the first type of special function. Now the second type is called onto. So what is meant by onto? Onto is like, imagine the set of the right-hand side set. Okay. So the codomain is a floor, and then you have accidentally, so it is a floor, and then you drink something, and accidentally you drop you drop your cup. What will happen? The liquid inside the water or the juice inside your cup will spill over the floor, right? So what will be the worst case? The worst case is every part of this one is covered. So your juice is completely filled onto the floor, right? Okay. So an onto function has a similar meaning. It means that all the things in the codomain has something mapped to it. So it means that the range is equal to the codomain. Is that okay? So onto function is a case that the range turns out to be equal to the codomain. And this is onto. So nothing is wasted in the codomain. And for this one, onto function, it also has a different name. So sometimes we call it a surjective function. Or simply, we call it a surjection. Okay, so surjection is not a common English word, but somehow you can think of it like injection is to put something into it. Surjection is still to put something, but over the whole surface. Okay, so over the whole surface. Everything on the surface is completely covered. So this is how you may try to remember that a surjective function is an onto function. and an onto function, it means that the range turns out to be exactly equal to the codomain. Okay? And now, finally, there is a third function, the third type of special function. It is called one-to-one onto, or sometimes one-to-one onto. Okay? So what is a one-to-one onto? So it is a function that is both one-to-one and onto. So a one-to-one onto, you can imagine, it means what? Everything in A, it can find something in B, right? And no two things in A map to the same B. But on the other hand, everything in B, there is only one thing from A mapped to it. Is that okay? So it means that if you pick any one thing in A, you know what is the thing in B, because there is only one, of course. But on the other hand, if you pick anything in B, you know that there is something in A mapped to it, because the range it is onto. You know something is mapped to it. And there's only one thing mapped to it. So it is also called a one-one correspondence. Is it okay? You pick anything in A, you know what is in B. And if you pick anything in B, you also know there is exactly one thing in A correspond to it. So it is sometimes or more commonly called a one-one correspondence. So this function, we just call it a one-one correspondence. Correspondence. Or it also has a name, so it is also called, this time it is called a bijective function, or simply called it a bijection. Is it okay? So bijection means that both direction. So both direction looks like an injection. Is that okay? Now when there is a one-to-one correspondence, so let's say there is a set A, there is a set B, and so there are some items in A and some items in B. Then what do we know? We know that if there is a one-to-one correspondence, the cardinality of A has to be the same as the cardinality of B. You cannot have more things in A than B, because in that case, you cannot have one-to-one. You cannot have more things in B than A, because in that case, it cannot be onto. Is that okay? Right? So they must have exactly the same number of things. It is just like if things are finite, it is just like a rearrangement, a permutation. Okay? If things are infinite, then that means that the cardinality of this one must be the same as the cardinality of this one. So you cannot have a bijection between integers and real numbers, because they don't have the same cardinality. But you can have injection, you can have one-one correspondence or a bijection between the integer set and the set of prime numbers. Okay? It is because they have the same cardinality. Is that okay? You may. It depends on the function. You may have. But if they don't have the same cardinality, it's never possible. Is that okay? Now when we have an injection, when we have a bijection, what do we know? Unique things in A maps to unique things in B. So that the arrow, you can reverse it. You can reverse it. When you reverse the arrow, it is also a function. Is that okay? So we call it so when there is a one-to-one correspondence, we can define, so in this case, we can define something called the inverse function. So the inverse, so we can reverse the direction. The inverse of f exists. And it is denoted by, so if you have a function f, the inverse is usually denoted by f minus 1. Okay, so it has a prop. So what does it mean? It means that fa is equal to b if and only if F inverse of B is equal to A. Okay. Okay, so this is it. Okay. So let's check our understanding. So bijection, injection, so we can have a lot of examples to check.